This lesson is about finite geometric series. So once again, we're looking for Sn, but this time we're doing it for a geometric sequence. We're adding up the terms of a geometric sequence. I goes from 1 to n of g sub I. And of course, g sub I is given by g1 r to the I minus 1. Again, I'm using I inside the sigma because n is the number value of the last term, and so I can't use it in the index in the sigma notation. I have to use some other letter. In this case, I used I. But I only point this out again because sometimes you might encounter this and you need to recognize that that's what's going on. So keep that in mind, that you might have to figure out you might have to recognize a geometric series when it looks something like this. So again, I derived the formula that's over here in Algebra 2. I'm not going to do it again. It is re-derived in the textbook if you'd like to look, but they show you how you can get that shortcut formula. So ultimately, this is the formula that I taught you in Algebra 2, and I'm going to continue to use it going forward. Again, I use G because I prefer it for geometric. It's just much easier to do that. The formula sheet or the formula booklet writes it this way: Sn equals u1 and then r to the n minus 1 over r minus 1. And then it also gives this version, u1 and then 1 minus r to the n over 1 minus r, which is the one I prefer, although technically this one is correct. And then it also indicates that r cannot equal 1, which makes sense. You can't divide by 0. So if r were equal to 1, you'd be in trouble. So obviously we're not going to worry about that one. All right. Find the sum of 2 plus 6 plus 18 plus 54 plus ... to 12 terms. Now you start to see why it's necessary to point out what kind of series this is. Notice that you're multiplying by 3 each time to get to the next term. So this is geometric. So the first thing I'm going to say is geometric series. That way I'm communicating, hey, by the way, I'm going to use the geometric series formulas rather than the arithmetic series formulas. So Sn now is, I just write it down, g1, 1 minus r to the n over 1 minus r. Okay, so to figure this out, I need to know g1, that's the first term, I know it. I need to know the common ratio, multiply by 3, multiply by 3, multiply by 3, so r is 3. And I need to know how many terms there are, 12, it told me that too. So I've got everything I need, I don't have to think about it too much. So it's just s sub 12 now. G1 was 2, and then 1 minus r we said was 3, and then raised to the 12th because there's 12 terms, and then over 1 minus 3. And literally I just plug this into my calculator, and I get 531,440. And again, don't round these because these are sequences in series. You want the exact answers. All right, find a formula for the sum of the first n terms of this series, 9 minus 3 plus 1 minus 1/3. Again, I recognize this is geometric because you're multiplying by negative 1/3 each time, or if you take this one divided by that one, or that one divided by that one, right divided by left, right divided by left, right divided by left, you get negative 1/3 each time. So first thing I'm going to mark it, I'm going to state as geometric series, so everybody knows that's what I'm supposed to be dealing with. And if you want to write what G1 and R are, you can. I'll do it this time anyway. G1 is 9 and R is negative 1/3. But ultimately, when you find Sn, which is what it wanted, the sum of the first n terms is just called S sub n. We can just plug those numbers in directly. I'm using the G1 1 minus R to the n over 1 minus r formula. So it's going to be G1 was 9, 1 minus, and then negative 1/3 raised to the n, all over 1 minus and then negative 1/3. And of course I can do a little bit of simplification because 1 minus negative 1/3 is 1 plus 1/3, which is 4/3. So I can call this 9 over 1 times 1 minus negative 1/3 to the n. By the way, I cannot make this into a positive because I don't know how many negatives there are because it's negative something to the n. So this negative and this negative does not make a positive since I don't know how many of these there are. But in the denominator, I can write this as 4/3, and then I can do the flip thing with the denominator, multiply by 3/4. So I end up with Sn equals, I'm going to put the 3/4 in front for a reason, 3/4 times 9 over 1 times the 1 minus negative 1/3 to the n like that. And the reason I put it in the front instead of on the back is because I can multiply these two together quickly and get 27/4. So it's 27/4 times the quantity 1 minus and then negative 1/3 raised to the n. And that's as far as I can go, so that's where I'm going to stop. Now technically you had answered the question right here, although again I can't say for sure that you wouldn't be expected to simplify, but maybe you would be able to get away with just that version. All right, a geometric sequence has first term 5 and common ratio 2, a geometric sequence. The sum of the first n terms of the sequence, now we're talking about a series, is 635. Find n. All right, so the sum, Sn, is going to be g1 times 1 minus r to the n all over 1 minus r. Well, do I know r? Yes. Common ratio 2. Do I know g1? Yes. First term 5. Do I know n? No, that's what I'm looking for. Do I know Sn? I do know Sn. It's 635. That's the final sum. So I do 635 equals g1 we said was 5. 1 minus r we said was 2, so 2 to the n, all over 1 minus 2. Well, 1 minus 2 is just negative 1. So why don't I multiply both sides by negative 1, and I get negative 635 equals 5 times 1 minus 2 to the n. Divide both sides by 5. So I get negative 127 equals 1 minus 2 to the n. Subtract 1 from both sides, so negative 128 equals negative 2 to the n. Multiply both sides by negative 1 to get positive, so 128 equals 2 to the n. Now you may actually know 2 to the what equals 128, but if you don't worry about it. You could probably guess and check this one, but I think it's easier to just use logs. That's what I'm going to do. Log with base 2 of 128 is going to equal n, and I use my change of base formula. Natural log of 128 over natural log of 2 equals n. And I end up with n equals 7. And that is a reasonable answer because n has to be a positive integer. It's how many terms there were. 7 terms makes total sense. Okay, consider the series 120 plus 60 plus 30 plus 15 plus ... How many terms are required for the sum to exceed 239.8? All right, first thing I notice is this is geometric. So I'm going to say geometric series. So the formula is going to be Sn equals g1, 1 minus r to the n over 1 minus r. And now I also notice that g1 is 120, and each time we're multiplying by a half. That's why I knew it was geometric. So r is 1/2. And we want the sum to exceed 239.8. So let's go ahead and plug the numbers in I know so far. Sn equals g1 we said 120, 1 minus and then 1/2 to the n over 1 minus and then 1/2. Now I want that to be greater than 239.8. Now I'm actually not going to try to solve that. I'm going to try to solve as if it was equal to. So I'm going to pretend 120 times 1 minus 1/2 to the n over, well, let's go ahead and subtract 1 minus a half. It's just a half. Is going to equal 239.8. So again, if I'm dividing by a half, it's the same as multiplying by 2 over 1. So I can just make that 240 times blah, blah, blah. So 240 times 1 minus 1/2 to the n equals 239.8. Now let's divide both sides by 240 and leave it. Don't try to simplify because it's going to get ugly. So 1 minus 1/2 to the n is going to equal 239.8 over 240. And now let's subtract 1 from both sides. So negative of the 1/2 to the n equals 239.8 divided by 240 minus 1. And I don't like what the calculator is giving me for this one, so I'm not going to use the calculator version. I'm going to leave it the way it is, but I am going to multiply both sides by -1 to get rid of that negative, which basically just flips this around. So really we're saying is that 1/2 to the n equals 1 minus 239.8 over 240. Now, I'm going to show you something that does make this a lot easier, but if you don't notice it, it's okay because you can let the calculator do this calculation for you anyway. 1 is really 240 over 240, so when I subtract 239.8 over 240, I can call that 0.2 over 240 because I had 240 minus 239.8 on the numerator and then just 240 in the denominator. So this is a slightly nicer looking way to write this expression, but again, you're going to use a calculator, so it doesn't really matter. And now we're going to use logs to solve 1/2 to the n equals this. So log with base of 1/2 of the 0.2 over 240 is going to equal n, and of course I use my natural logs, so change of base, natural log of 0.2 over 240 over natural log of 1/2 is going to equal n, and I get n equals 10.2288 1869. And now I need to interpret this a little bit. Remember, don't just blindly round this. You certainly can't round to 3 sig figs because n is the number of terms. And if you want your sum to exceed this number, remember these numbers as you keep adding keep getting bigger and bigger and bigger. So you want to make sure you go past whatever that was. So even if you round it to 10, you haven't quite made it. So we're going to say use 11. In other words, you need 11 terms. That way you've guaranteed that you've exceeded the 239.8 that you were attempting to exceed. Okay, I want to evaluate this sigma expression. All right, well, first of all, this doesn't exactly look like a geometric series. However, I do recognize that it's 3 times 4 to the something. So as k keeps changing, I keep multiplying by more and more and more 4s. So it is geometric. 4 is the common ratio. So I'm going to mark that down as geometric. And then I'm going to say the word series because when you do the sigma, you're adding stuff up. So it's a series. R equals 4. Now the formula, I'm going to write it in a thought bubble here. For the sum is Sn equals G1, 1 minus r to the n over 1 minus r. Remember, G1 is the first term. It is not necessarily this thing here. It is whatever the first term is. So in this scenario, you start this calculation with k equals 2. That is the first thing you do. So the first term, I'm not going to call it G1, but I'm going to say first term equals 3 times 4 squared, which of course is 3 times 16, so 48. So actually the first term is 48. Now remember, in this formula, n is the number of terms. I'm starting at k equals 2, and I'm going to k equals 7. If I just did 7 minus 2, I'd get 5. But that doesn't take into account that I have to use the k equals 2, and I also have to use the k equals 7. So there's actually one extra term in there. Or count it this way, 2, 3, 4, 5, 6, 7. So it's not 5 different things, but 6 different things. So there are 6 terms. And it's because I have to use the k equals 2 and the k equals 7. So if I do 7 minus 2, that is not the number of terms. It's less than the number of terms by exactly 1. So 1 more than 7 minus 2 is going to be the number of terms. Now again, I did not call this G1 and I did not call this N. I don't want to confuse myself because this is not written exactly in the way I want it to be written. So I'm not going to use that notation. I just thought about it in my head about what was the formula telling me. How do I adjust it for this? So now to figure out sigma k equals 2 to 7 of 3 times 4 to the k, I can now use the geometric series formula, this one using first term 48 and 6 terms. So it's 48 times 1 minus r was 4, so 4 to the 6th all over 1 minus r is 4, and I plug that into my calculator. And again, no rounding here. I get 655 to 0. Now I want you to be very careful with this one again. It kind of looks like G1 and R and so on and so forth, but it isn't really, because I'm starting at some weird spot. I didn't have I minus 1 or n minus 1 in the formula. So things aren't quite exactly right, but it is geometric because you keep multiplying by 4. Every time k changes, you multiply by another 4. So it is a geometric series, and r is 4. And so I can use this formula, but I have to be careful. First term does not mean G1. First term means what would I plug in first and what would I get? When I plug in k equals 2, it's 48. 6 terms, because I went from 2 to 7, subtract 7 minus 2, I get 5, but that's missing it by 1. So I actually have 6 terms total if I start at 2 and end at 7. And then finally, I use the formula. G1, remember, just means first term. N means number of terms. And of course, R is a common ratio, which I had figured out. And that's how I ended up with my answer. But notice that nowhere in this work did I write Sn or N or G1. You could probably get away with it, but I wouldn't recommend it because G1 looks like 3 here, but it isn't. N looks like 7 here, but it isn't, etc. So you got to be a little careful how you interpret and what you write down. I still use that formula. I just had to be careful and clever how I did it. And that is the end of the lesson.